Hello students, welcome to Turito. In today's lecture, we are going to learn some fundamental ideas of grouping. When you want to group some objects or things or people into different groups, how do we do that? What is the fundamental idea behind it? Now, you might have studied some formulae in some books or in some notes or through some online lectures. But remember that our main goal of learning is not to use the formula, but to develop our own formula. So, when you are able to develop your own formula, that means your learning is good, that means you have learned it perfectly. Okay. So, how do we learn this idea of grouping? So, any concept has a fundamental crux and a fundamental idea. So, grouping is basically selection. This is the fundamental idea of grouping. Now, whenever we want to understand the process of grouping, we have to understand the process of selection. Now, we already have understood the process of selection from our first lecture. So, when we select any two objects or three objects, so there is a kind of symmetry because order of selection is not important. So, we divide with certain factorials. You recall that idea? We are going to use the same idea here and we are going to progress. Okay. So, before that, remember that, or please note that grouping is basically selection. So, when we are performing division of things into groups, basically we have to select objects and form the groups. Okay. So, now let me apply this idea on one or two illustrations and see how the process look like. Suppose let us say there are 10 objects and we want to group these 10 objects into two groups. One group is having 7 objects, other group is having 3 objects. So, how do we do that? Now, language is very important in this chapter. So, let me explain it here. Whenever 10 objects is mentioned, now because it is not mentioned that they are identical, you have to assume that they are different. Okay. So, if they are identical, they will mention it. If nothing is mentioned, then naturally they are different. So, here these 10 objects are different objects. Now, how do we form a group of 7 from 10 objects? You have to select 7 objects from the given 10 objects, right? So, in how many ways we can do that? In 10C7 ways we can do that. So, basically when we want to form a group of 7 from 10 objects, we do it in 10C7 ways. Basically we have selected 7 objects and we formed a group. Now, how many are remaining? 3 are remaining. From those 3 we want to make a group of 3. So, in how many ways we can do that? From 3 you want to select 3 and that is always one way. You can also write that 1 as 3C3 or you can also write it as 10C7 into 1. So, when we are forming a group of 7, automatically the group of 3 is automatically formed. So, that is always one way. So, when we are forming one group, if the other group is automatically getting formed, then that second group will have only one way. So, this way we can conclude that these are the total number of ways of forming a group. Okay. Now, if we open this up, what do we get here? We will be getting 10 factorial by 3 factorial into 7 factorial, right. Now, you can also understand it this way, because first group is having 7 objects, there is 7 factorial in the denominator. Now, the second group is having 3 objects, so there is 3 factorial in the denominator. So, this way you can also understand this as a formula. So, where in the numerator the total factorial will come and in the denominator the factorials of each group will come. Okay. So, you can also remember it this way or you can also remember it as a process of selection. Okay. So, with this we have kick started our process of grouping. I hope you have understood the logic. Okay. So, now can we do the same thing to the next question? So, let us say we have 10 objects and we want to form 3 groups. First group is having 5 objects, second group having 2 objects, third having 3 objects. So, how do we do that? From the 10 we want to form a group of 5 and then want to form a group of 2 and then want to form a group of 3. So, how do we do it? First we select any 5 from the given 10, and now 5 are already grouped. Now we want to select any 2 from the remaining. How many are remaining? 5 are remaining. So we formed group of 2 objects, and then 3 are remaining. We want to form third group which is having 3 objects. So that's only one way. So this way we can complete the process of grouping. Now still if you want to observe the formula here, we can expand this and observe it. So let me just expand this. So we will be getting 10 factorial by 5 factorial, 5 factorial into 5 factorial by 2 factorial into 3 factorial. This is our 5C2, this is our 10C5. Now see if there are any terms which are getting cancelled. This 5 factorial is getting cancelled. Now what is remaining? 10 factorial by 5 factorial into 2 factorial into 3 factorial is remaining. Now here we can understand that there are 3 groups here. Each group is having 5, 2, 3 number of objects, and whatever is that number inside that group, we have to divide with those factorials. So this way you can also understand the formula. Okay. Now here if you observe, 5 plus 2 plus 3 is basically 10. So that means every object is being grouped. Similarly, if you also observe the earlier case, here also 3 plus 7 is equal to the total objects available. So this is something that you have observed in these 2 examples. Now what happens when these 2 are exactly not equal? That we will see in the next example. Okay. But before that, let us understand this process of grouping only. Now when we formed group of 7 and 3, first we formed the group of 7, then we formed the group of 3. Let's say you have decided otherwise. Let's say you wanted to form a group of 3 first, and then you wanted to form a group of 7. Then what will be the numbers? First we will be selecting 3 objects. So formed a group, and then we will be selecting 7 objects from the remaining objects. Now how many are remaining? 7 are remaining. So into 7 is 7 or into 1. Now this number and this number are going to be exactly equal. Now what is it actually telling you? It is telling you that while grouping, your order of grouping does not matter. No matter in which order you are going to group it, it's going to be the same number. Now if we do it for the next question also, we are going to end up with the same number. For example, here I first formed a group of 5, then group of 2, then group of 3. Let's say I chose to form group of 2 first. So that means I will be first selecting 2, right? And now from the remaining 8, let's say I wanted to form the group of 3. So that means it will be 8C3. And now 5 are remaining, we want to form a group of 5. So that's only one way. Now if you simplify this number also, it's going to be exactly same as this number. So these 2 are going to match cut to cut. So which means again order of grouping is not important. Okay. So here there are 2 observations that I have noted, and I hope you are making a note of that. One is, no matter in which order you are going to form the grouping, you are going to get the same number. So that means order of grouping is not important. And the other is, whenever we are forming groups here, the sum of numbers of all groups is equal to the total number. Now what happens if it is not exactly equal? That we will see little later. But before that, you have to surely make a note of this. Okay, come on, make a note of this. Now let's say we take a different question. Here we want to form 20 objects into 3 groups. We want to divide 20 objects into 3 groups. Okay, so look at the language. Forming groups, dividing them into groups, distributing them into groups, all these are going to mean same. Okay. Now here coming to this, 20 objects are there, and how many groups are there? 3 groups are there, and each group is having 5, 2 and 3 members. Now if you add these 3, the summation is 10, and which is definitely not equal to total. Total is 20. So then what happens? Then there could be a confusion. But let us start it from the fundamentals and try to understand what is happening in the process. Okay. So what do? First we form any one group. Okay. So from the 20 available objects, we let us say form the first group of 5. That can be done in 20 C5 ways. And now how many are remaining? 15 are remaining. From these 15, select any 2 objects. That you can do in 15 C2 ways. Now how many are remaining? 13 are remaining. From 13, make a group of 3. So that means select 3. So you can do it in 13 C3 ways, right? So if you open this up, you will get the total number that is required. Now let's open this up and see. But if you understand it from the process of selection, there is not much change here. When we were forming groups, what is the idea? Grouping is nothing but selection. So from the available objects, we kept on selecting whatever is required for that particular group, and we went on with that and we got a number. Now let us expand this number and see what exactly are the factorials that are coming, and is it in sync with our discussion earlier we had. Okay, so let me just simplify this. 20 C5 can be written as 20 factorial divided by 5 factorial into 15 factorial, and 15 C2 can be written as 15 factorial by 2 factorial into 13 factorial, right? Similarly, 13 C3 can be written as 13 factorial by 3 factorial into 10 factorial. Now see if there are any terms which are getting cancelled. 15 factorial is getting cancelled and 13 factorial is also getting cancelled. Now what are the remaining terms? In the numerator we have the total factorial. This is in sync with our discussion. Now what are the other elements here? There are 5 factorial here. This is for the first group. In the second group there are 2 elements, and here there is 2 factorial. So this also is in sync. Now third group has 3 objects and there is 3 factorial here, but there is one extra factorial. What is it? It is the 10 factorial. Now what is the meaning of this 10 factorial? Earlier we said if there are some groups, every group has a number of objects and that number of objects will come as factorial in the denominator. But we formed only 3 groups, but we got one extra factorial. What is the meaning of this extra factorial? It means when you are forming these 3 groups, there is another group which is automatically getting formed, which is whether knowingly or unknowingly, indirectly, there is one more fourth group which is being formed, which is not being grouped. Okay. So you can also understand it like this. Let's say there are 20 marbles on your table. Okay. So 20 marbles you have kept on your table, and out of these 20 marbles you wanted to form a group of 5 marbles. How do you do that? You just select any 5 and separate them. So you have them on the table and you just separated a group of 5. Then you separated a group of 2. Then you separated a group of 3. Now there is another pool of marbles which are 10 and which are not going into any of these 3 groups. But if you notice on the table, there are now 4 groups present on the table. So basically indirectly you have formed another 4th group which was not originally part of the plan. Okay. So when you are applying formula directly, you have to also understand that there could be another group which you are unknowingly forming. So you have to remember that and you have to counter it using that 10 factorial. So if you are remembering the formula, if you are going by the formula, you have to make sure that there is an explanation for that extra factorial, and you have to make sure that you put it when you are calculating. But if you go by the selection process, if you remember that grouping is nothing but selection, you don't have to remember that 10 factorial, right? So that is exactly why I keep stressing that remember that grouping is selection, you don't have to remember the formula. Okay. So come on, make a note of this and also make a note of that important point that I have discussed. Okay. Okay. Now, let's take a different question. So, till now we have understood that grouping is nothing but selection, right? First point. Second point, while grouping, order of grouping is not important. Now, third point, when we are using the formula, there could be one extra factorial which is coming because of the unknowingly indirect group that is being formed, right? Now, the fourth point is this. Fourth point comes from this example. So, here there are 4 objects, you wanted to form 2 groups and each group is having 2 members. So, how do we do it? If we go by the current knowledge, whatever is the knowledge that we have built till now, if we go by the current knowledge, this number is going to be 4C2 into 2C2, or 2C2 can be written as 1 also. Or if we go by the formula, it will be 4 factorial, that is the total factorial, divided by factorial for each group. So, there is one group which is having 2 numbers, 2 objects, so 2 factorial. Other group is having 2 objects, 2 factorial. Now, what is this number going to be? So, let me just simplify this and write 4C2 is going to be 6. So, this number is going to be 6. But this is wrong. Why is it wrong? We are going to explore this by taking some objects. Okay. So, let me take some objects here. So, let us say the objects are A, B, C, D. Let us say these are my 4 objects and we want to form this into 2 groups, right. So, let us take 2 groups here. Let us say there is group 1 and let us say there is group 2. Okay. Group 1, group 2. Now, if I take let us say A and B in the first group, then C and D will go to the second group, right. So, if I take A and B here, C and D will be in the second group, or if I take AC here, second group will be having B and D. Similarly, if I take AD here, this group will be having BC. Now, again here I keep changing the first group, based on this I am writing the second group. Okay. So, suppose let us say I take BC here, this will be having AD, and if B and D are here and here there will be A and C. If C and D are in the first group, AB will be in the second group. Now, total how many ways are there? So, this is one way, this is one way, this is one way, one way, one way. So, total we got how many ways? Total we got 6 ways. Okay. So, this is 6 ways of grouping. Okay. Now, put this scenario on a different situation. Let us say you are having these 4 objects on your table and you are forming 2 groups here of 2 members each. So, let us say from these 4 you separated A and B and you kept it aside, then automatically the other group is having C and D, right. So, you separated A and B here and here there are C and D, or you separated A and B here, then C and D will come here. So, these 2 processes are actually same, right, because AB is one group and CD is the other group. No matter where you place these 2 on the table, it is going to be same, right. So, what does it mean? It means this first case and the last case are actually equal. First case and last case are actually equal. So, that means this case and the last case, these 2 are exactly equal. Similarly, this second case and the last second case are also exactly equal. Also, these 2 are exactly equal. So, there is a symmetry in the process of grouping. Okay. So, here if I let us say there is a name of the group. Okay. So, let us say I name this group as Mumbai and I name this group as Hyderabad. Okay. So, now Mumbai and Hyderabad, these 2 are having 2 different names of the groups. Okay. So, AB coming in Mumbai and CD coming in Hyderabad, CD coming in Mumbai and AB coming in Hyderabad, these 2 are 2 different cases if I named them as Mumbai and Hyderabad. Let us say there is a name, there is no name here. So, when there is no name and when there is no number also for groups, let us say group 1, group 2, that number is also not there, then AB coming here, CD coming here, or CD coming here, AB coming here is actually same. So what does it mean? It means that there is a symmetry in the process of grouping. Now what is the logic? The total number of ways are going to be only 3 here. So we are going to cut down these. Okay, so let me just talk about this symmetry. So this is the symmetry. Okay, so we are going to cut down these. Okay, so we are going to cut down these exactly here, and we are going to say that the total number of ways of grouping are going to be only 3. So now what have we learned here? We have learned that when the number of objects in the groups are equal, then there is a symmetry in the process of grouping. So we have to balance that symmetry. To balance the symmetry, we have to divide with the symmetry. Okay. Now recall our first lecture, we divide when there is symmetry. So what do we do here? We have to divide with 2 factorial. Now what is this 2 factorial representing? It is representing the symmetry. Now similarly, if 3 groups are going to have the same number of objects, then of course there will be symmetry, and in that case we will have to divide with 3 factorial. You know how that symmetry comes, that I have explained in the first lecture itself. Okay. So basically what have we learned in this question? In this question we have learned that whenever the number of objects in the groups are equal, then we are going to divide with the symmetry, and that symmetry comes from the how many groups are being having same number of objects. So that factorial will become the quantification of symmetry. Okay. So I hope you have understood the logic. Now based on this, you also need to make a note. When there is symmetry, we divide. When groups are having same numbers, then there will be symmetry. Okay. Come on, make a note of this. Okay. This page also. Now let's solve a different question based on the same idea. Now there are 10 objects here, nothing is mentioned, so objects are different. They have to be grouped into 3 groups. One is having 3 objects, other is having 3, other is having 4. So how do we do this? So there is 10 here, 3 in one group, 3 in other group, and 4 in the last group. So how do we do it? If we are going by the micro method, micro is the selection here. So first we make a group of 3, then from the remaining 7 we make a group of 3, from the remaining 4 we make a group of 4. Now because two groups are having the same number, there is a symmetry in the process of grouping, so we divide with 2 factorial. Okay. Now similarly, if you go by the formula, how do you do that? Total factorial comes here divided by, before you write the other factorials, make sure that sum of 3 numbers is equal to 10. So is it equal? Of course here 3 plus 3 plus 4 is 10. So we can directly write here 3 factorial and 4 factorial. Okay. So now there is no extra group that is being formed, so extra factorial will not come. Now there is a symmetry in the process, so you have to divide with 2 factorial here. Okay. So whenever we form any groups here, there could be 2 extra factorials. One could represent the extra unknowing group that is being formed, and the other could represent the symmetry. So there could be 2 extra numbers here. So be little careful with those 2 extra numbers. Okay. So this way we can form grouping whenever the number of objects in the groups are equal. Okay. Come on, make a note of this. Okay. So now let's go to the next problem. Here there are 20 objects and we have to form how many groups? We have to form 6 groups. So let's have a look at the process here. Now there are 20 objects. How many groups are being formed? Total 6 groups. First 2 groups are having 4 objects each. Next are having 3, 3, 3, 3. Okay. Now before we proceed, make sure that the summation is equal to 20. Okay. If it is not, there will be an extra factorial. So I am going to use the formula directly here. 4 plus 4 is 8 and 4 into 3 is 12, 12 plus 8 is 20. So sum of all these is equal to 20. So that means we can say that it is going to be 20 factorial divided by 4 factorial is coming 2 times. So 4 factorial square, and because these two groups are having the same number, there is a symmetry of grouping. So 2 factorial will come, right? This is the symmetry. Now again there are 4 groups which are having 3 members each. So that means 3 factorial will come how many times? 4 times. So raised to 4, and now because all these 4 groups are having the same number, now there is a symmetry in the process. So 4 factorial will come. So this way we can perform the grouping. So here if you just simplify this, you are going to get 20 factorial by 2 factorial into 3 factorial raised to 4 into 4 factorial raised to cube. So if you look at this answer, you may not be able to justify what has happened, but here it's clearly mentioning, these numbers are clearly talking to you what is happening here. Okay. So we can also say that this term represents symmetry and this term also represents symmetry. Okay. So this way we can understand grouping whenever the number of objects in the groups are same. Okay. Come on, make a note of this. Okay. Now let us have a look at whatever we have understood here. Let us have a look at the conclusions. So let us say there are n distinct objects and you want to split them into R groups, and each group is having A1 members, A2 members, A3 members and so on till AR. So what happens when we go by the formula? If A1 plus A2 and this entire summation till AN, if this is equal to the total number, then all these factorials will come here. Of course, there should be one factorial here. Okay. But if it is not exactly equal, if this LHS is less than n, there will be one extra factorial here. So in both these cases, assume that sum of all of them is equal to n. Okay. Now here all AIs are unequal, which means every group is having a different number of objects. What if some groups are having the same number of objects? Then we have to divide with the symmetry. So let us take a case where number of objects in k groups are same. Number of objects in k groups are same. Then that means there should be one extra k factorial in the denominator. Okay. So of course it's a mistake. So a3 factorial. So basically whenever number of objects in the groups are same, we have to divide with that factorial. Okay. Now let us take up another idea. Here you have to understand this basic difference of grouping when named and unnamed groups or these terms appear in the question. So whenever named groups appear, what to do? Whenever unnamed groups appear, what to do? So here you have to understand that unnamed groups means your groups are not being named, so that means there will be symmetry of grouping. Whenever the groups are named, symmetry of grouping will not be there. Let us go back to the earlier idea of symmetry. Probably then you will understand it in a better way. Let us look at this. Here this group and this group do not have any names. So that means on your table when you had 4 objects, you separated A and B, automatically C and D got separated. So A and B is one group, C and D is another group, and that got symmetry here, right? Suppose let us say you have kept the first selection as your first group, let us say you named it as Mumbai, and you have selected the second group as your second group, let us say you named it as Hyderabad. Then here because you named it, AB going in the Mumbai and CD going in the Hyderabad group, and AB going into Hyderabad, CD going into Mumbai, these two are now different groups, right? So, whenever we name the groups, let us say I name this group as 1, this group as 2, if I number the group or name the group, then automatically symmetry will not be there. So, that means we do not divide if they are named groups. So, that is what you have to basically understand here, okay. So, whenever we talk about named groups and unnamed groups, only in unnamed groups we divide with the symmetry. If it is mentioned that the groups are named groups, then you do not divide with symmetry, okay. So, that is what you have to understand. If groups are named, then we do not have to divide with symmetry, okay. But what if nothing is mentioned? If it is not mentioned whether it is named group or unnamed group, what is the default case? Default case is unnamed groups. So, if nothing is mentioned, you have to assume that it is unnamed group and you have to divide with symmetry, okay. So, this way your confusions will be cleared whenever you are solving the problems, okay. So, I took up this discussion only to help you while solving the questions. Whenever you encounter any such words in the question, remember what I told here, okay. Come on, make a note of this. Now, let us take up a different idea. So, till now we have understood what is grouping and what is the main logic behind grouping, what is the formula and what is the extra factorial in the formula and what is symmetry in the process of grouping, how do we balance the symmetry, we have understood everything. Now, let us take up a different idea. Here, instead of taking different objects, I have taken identical objects. So, I want to group 10 identical objects into 2 groups. One group is having 7 objects and the other group is having 3 objects. So, how do we perform this grouping? Now, remember that if you just use the formula, you are not going to get the answer, okay. So, you have to understand the logic and you have to apply the logic. Now, go back to the basics. What are the basics? Grouping is nothing but selection. So, let us select 7 objects from the 10 identical objects, okay. So, in how many ways we can do that? In general, if we are grouping like this and let us say they are different objects. For different objects, we select any 7 from the 10 in 10C7 ways and from the remaining 3 we select any 3 in 3C3 ways, right. Now, what happens when the objects are identical? So, if the objects are identical, in place of 10C7 we will get only one way, because you can select any 7 objects from the given 10 identical objects in only one way, because when objects are identical, any selection is only one way, and from the remaining 3 can be selected in one way only. So, what is the answer? It is just one way. Now, no matter whether groups are going to have equal number of objects or unequal number of objects, always the total number of ways of grouping is going to be one way only. So, remember, if identical objects come, your grouping ways are going to be only one way, okay. Now, let us conclude this. N identical objects can be split into any number of groups. Here, it need not be just 2 groups, any number of groups having any number of objects in only one way, okay. So, this is the conclusion of this illustration, okay. So, you know my style of teaching. First, I give you an example, I create an idea in your mind and then I develop a formula based on that, okay. Come on, make a note of this. This page also. Now, there could also be a different idea. So, sometimes questions may also come like this: form 3 groups and distribute them among 3 persons, form 3 groups and distribute them among 3 cities. So, whenever that kind of situation comes, you may have to perform the grouping first and then you have to perform the distribution or arrangement. Okay. So, this is a tip for problem solving. We will be solving one such problem in the coming up collection. Okay. So, now let us go to solving process. So, in today's lecture we are going to solve at least 3 problems based on the ideas that we have discussed till now. Okay. So, this is our first question. 4 identical objects, 4 different objects want to be grouped into 2 groups, and in one group there are 3 objects, in other group there are 5 objects. Now, remember here, total objects are not exactly different. If they are completely different, we have a formula. If they are completely identical, there is only one way, but it is a mixture. So, there are some different objects, there are some identical objects. Now, how do we group them? Now, you have to go to the fundamentals, make cases and handle every case separately. So, this is going to be micro method. So, as you remember, when cases get complicated, when there is a mixture of different things, then idea is to go for micro method. Okay. So, what do we do here? We make 2 columns, one having the group of 3, the other is having the group of 5. Now, based on one group I am going to make cases. So, let us say I take this group because it is having the small number. So, going to 5 is going to complicate. So, let me take only this 3 case. So, whenever I am talking about this group of 3 objects, all 3 could be identical or all 3 could be different also, and there can be a middle ground also. So, we are going to list down all those cases. So, we can have all 3 identical objects, this is one case, 2 can be identical, 1 can be coming from the different objects, right, or 1 can be identical object, the other 2 can be different objects, right. Similarly, all 3 can be different objects also. So, these are the total possible cases. Now, how many total objects are there? Total objects are 8 only. Total number of objects are 8. So, if I am forming a group of 3 from the total of 8 objects, how many will be remaining? 5 will be remaining, and that is our second group. So, here if you recall our basic ideas, when we are forming a group of 3, automatically group of 5 is being formed. So, we only have to count the group of 3, because when you form group of 3, automatically the next group will be formed. So, that next group will have always one way. Okay. So, how do we proceed with that? So, first case, what is the process of grouping? It is nothing but selection, right. So, we have to select 3 identical objects from 4 identical objects. In how many ways we can do that? In only one way. So, in only one way we can select any 3 identical objects from the given 4 objects. Now, whatever are remaining will be termed as the second group. So, that means for second group there is only one way. So, the answer is 1 for this case. Now, let us do it for the second case. 2 identical objects and 1 different object. So, that means from these 4 I have to select 2 identical objects. In how many ways I can do that? I can do this in one way, because always selecting identical objects is going to be only one way. Now, 1 different object must be selected from how many? 4 different objects. So, that means this will be 4C1. So, here I formed the first group, but what about the second group? It naturally has one way, because it is automatically getting formed. Okay. So, this value is going to be 4. Now, similarly the next case, 1 identical, 2 different. So, how do we do this? 1 identical, 2 different. So, 1 identical can be selected in one way and 2 different can be selected from 4 different. In how many ways? 4C2 ways, and naturally the second group is getting formed in one way. So, this is going to be 6 ways. Okay. Now, further 3 different. So, this can be done in 4C3 ways. Now, automatically second group will be formed, and this is going to be 4. Now, what is the total here? It is going to be 15 here. Okay. So, in total 15 ways you can group these total 8 objects into 2 groups, and one is having 3 objects, while other is having 5 objects. So here what you have understood is, if there is a mixture, then you go for micro, you go for case by case. When you are handling each case separately, remember that grouping is nothing but selection, so use the selection only to solve the question. Okay, come on, make a note of this. Okay. Now, as part of the same question, let me take a slight different variety, okay, to explain you that the second group may not automatically get formed. Okay, so when we are forming first group here, second group is automatically getting formed, but second group sometimes do not get automatically formed. Then what to do? So let me take the same case. So there are 4 identical objects here, 4 different objects, and we want to form groups, right? So let me say that, okay, so I'll take it in a little different way. So I'll take 5 different objects. Okay, so total there are 9 objects. So let's say one group is having 2, other group is having 3, other group is having 4. Okay, 2, 3, 4. Now 2 plus 3 plus 4 is 9. Okay, so you don't have to form the third group, let's say. Okay, so let's say we want to form just only 2 groups. Now one group is having 2 objects, other group is having 3 objects. When you are forming 2 groups, third group is automatically getting formed indirectly. Our focus is only 2 groups, but third group will get formed. So here when we are forming the first group, second group does not get automatically formed. So we have to take cases for the second group. Okay, so let me start like this. Let's say my first group is 2 and the second group is 3. So what are the cases here? Both these can be identical, right? When first group is having completely identical objects, the second group may have a mixture also. So let me take all cases here, because 2 identical already went into this. Second group can have maximum of 2 identical only, because total identical are only 4. So let me start from here. 2 identical, 1 different. This is one case. The other case could be 1 identical, 2 different. The other case could be all 3 different, right? So these are the sub cases for the first case. So that means when we are forming first group, second group is not automatically getting formed. Now what could be the other case? Other case could be 1 identical plus 1 different in this case. Now here again we will be getting different cases. Okay, so because 1 identical is already taken here, so all 3 can be identical, or 2 can be identical, 1 can be different, or 1 identical, 2 different, or all 3 different. This is also possible. Now let me take another case for the first group. So here both of them could be different also. If both are different, how many maximum different that can come in the second group? Total 5 different are there, so all 3 can be different. Okay, so we can start like this: all 3 identical, 2 identical, 1 different. Now 1 identical, 2 different, or all 3 can be different. Okay, so here total 4 subcases came, here also total 4 subcases came. So now total how many? Total 11 subcases came. So you have to evaluate all subcases separately. See, now the problem got complicated when there is a mixture. Okay, so remember that whenever there is a mixture, we have to go by micro. So I will just solve few cases and show you how it is done. Okay, so let's say I take the first case. Now I have to select 2 identical from this 4 identical. So for the first group there is only one way. Now for the second group, I have to select 2 identical from the remaining 2 identical, that is only one way. and I have to select one different from the 5 different. So that is 5C1. This is the second group, and when we form two groups, automatically other group is being formed, which we anyways don't care, so we just stop it here. Okay. So if you are worried about the third group, that has only one way. Okay. Now coming to the next case. So for first two identical, it's only one way, and for the next case, so from remaining two identical, here one identical can be selected in one way, and from 5 different, 2 different can be selected in 5C2 ways. Okay. Now similarly the third case, here 2 identical is only one way, the same is getting copied here. Okay. Now 3 different, that means from 5 we want to select any 3. So this is the summation for the first case. Now again for the second case, we have to evaluate all of them. Okay. So this way we have to follow a different approach when it comes to the cases like this. Okay. So but let me just explain it here. So for this case, from 4 identical you want to select one identical, it's one way. From 5 different you want to select one different, it is 5C1. Now with this first group is formed, now we are going to the second group. Second group is having 3 identical. So from the remaining 4 identical, from the remaining 3 identical, all 3 should go to this. So it's only one way. Similarly the next case, so first group is having the same number of ways, but now second group will change because we want 2 identical, it's one way, and one different. First group has already taken one different. Now how many are remaining here? 4 different are remaining. From those 4, one will go to the second group. Okay. Similarly the next case, so it's the same way. So 1 into 5C1 into 1 for the identical, and there are 4 different left, so 4C2 for the different. So this way we have to form all cases and add them. Now this process could be lengthy, but what I have given here is a glimpse of what happens when there is a mixture. Okay. So when there is a mixture, be little careful while performing the calculation. Okay. Come on, make a note of this. Okay. Now let us solve a different question. So here in this question I have not solved it completely. So you know that the number of cases are going to be more, you just have to list down all of them and add them. Okay. But before I go into the next question, there could also be a doubt from your side. So let me explain that doubt. Whenever you are forming any group, okay, so whenever you are forming any group, let us take any one case here. So let us say A and B are in the first group. So in that group, we don't worry whether A and B are coming in the order AB or BA. So within that group, order is not important. So we know that order of grouping is not important, and order within the group is also not important. Okay. So you recall this for the process of problem solving, because order is never important in any of these cases. Now let us have a look at a different problem. Okay. So here there are total 36 distinct objects given, and you want to divide them into 9 persons. Okay. So 9 persons, that means 9 groups should be there, and you want to give one group to each person, right. So now here the first step of the entire problem solving process is going to be the grouping process, and the second step is going to be the arrangement. Okay. So let us have a look at this. Okay. So let us see if we have blank spaces. Okay. So how do we do that? So first try to observe how many groups are being formed, 9 groups, and 4 of them must be having 2 objects. So with 2 objects there are total how many groups? There are 4 groups. Okay. And with 3 of them getting 5 each, that means with 5 objects there are 3 groups. and what else? Remaining are getting 6 and 7. Okay, so these are the all groups. Okay, so this way I represent so that I don't commit any mistake while grouping. Now add all of them and see if it is matching up to 36 or not. If it matches, then we can directly apply the formula. If it doesn't match also, we can put that extra factorial. Okay. So 4 2s are here, that means 8, 3 5s are here, that means 15 plus 8 is going to be 23, 23 plus 7 is 30 plus 6 is 36. So it perfectly matched. So we can directly apply the formula. So here 36 factorial, total factorial comes in the numerator, and in the denominator these groups should come. So groups of 2 are 4, so 2 factorial raised to 4 will come. Because 4 groups are having the same number, now 4 factorial should come. This is for balancing the symmetry, and there are 3 groups of 5 members. So 5 factorial should come 3 times, and because these 3 are having the same number of objects, 3 factorial will come to balance the symmetry, and there is one group with 6 members and there is another group with 7 members. Okay. Now this represents the process of grouping. Now till here we have formed 9 groups, but there are 9 persons waiting there. Every person should be getting some objects, right? In how many ways you can do that? So this is just like distributing 9 chocolates to 9 persons, or placing 9 people in 9 seats. So that's going to be 9 factorial. Okay. So we have to multiply this with 9 factorial. So here if you understand, what have we done here? We have basically grouped first and then we did the arrangement. Okay. So this entire process is the grouping process, and this process is the arrangement process. Okay. And again in these numbers, if you remember, this is actually representing the symmetry, and this number is also representing the symmetry. Okay. So I hope you have understood the whole process of problem solving in this question. Okay. Come on, make a note of this. Okay. Now let's take up another problem. Here we have to prove that this is an integer. This certain expression is an integer, either by algebra or by permutations combinations. So how do we do that? So let me first explain the algebra. Suppose if you take 3 consecutive numbers, any 3 consecutive numbers, it's always divisible by 3 factorial. If you take 4 consecutive numbers, it's divisible by 4 factorial. If you take 5 consecutive numbers, divisible by 5 factorial. If you take n consecutive numbers, their product is divisible by n factorial. Okay. So here whenever I am talking about consecutive numbers, I am talking about the product of consecutive numbers. So product of any r consecutive numbers is always divisible by r factorial. Now this is exactly the reason why NCR is always an integer. Okay. For example, if you take NCR, okay, so let's take it here. So NCR can be written as n into n minus 1 into n minus 2 and so on till how many terms? R terms will come, and divided by r factorial. So this is a product of r consecutive natural numbers. It is always divisible by r factorial. Okay. So that is why NCR is always a perfect natural number. Okay. Now here we can also apply the same logic. Now how many numbers are there in the numerator? There are total n square numbers, right? So starting from 1, there are total n square numbers. Okay. Now let's take a segment of all these numbers starting from 1 till n. So I have collected them together. So this is a product of n consecutive natural numbers. Now starting from n plus 1, I will take all numbers till 2n. This is also a product of n consecutive numbers. and similarly starting from 2n plus 1, I will take all numbers till 3n. So this is going to give me again another product of n consecutive numbers. Now like this, how many such n consecutive numbers are there? Total n such groups are there, right? So this is 1, this is second, this is next. So n numbers here, n numbers here, n numbers here, and total n square numbers are there. So that means there are n such segments, okay? And there is n factorial raised to n in the denominator. So give 1 n factorial to this product, give 1 n factorial to this product, give 1 n factorial to this product, and give the last n factorial to this product. Now as we said, product of any n consecutive numbers is always divisible by n factorial. So this is a perfect integer, this is a perfect integer, this is also perfect integer, this is also a perfect integer. So the result is going to be a perfect integer. So this way algebraically we can understand that it is going to be a perfect integer. Now let us have a look at this from the permutations point of view. Now how many objects are here? Imagine that there are n square objects, okay, and you want to form some groups. So let us say each group is having n objects only. Now like this, how many groups are there? Total n groups are there, okay. You have n square objects and you want to form n groups. Now whether these groups are named groups or unnamed groups, the number has to be a perfect integer, right? The total number of ways of forming groups is going to be a perfect integer. You cannot have half ways, you cannot have -3 ways, right? So it is going to be a perfect natural number. Now what will be the number here? We have already learned the formula for grouping. So it will be n square factorial divided by n factorial is coming how many times? N times, right? So now if they are unnamed groups, we have to divide with symmetry. If they are named groups, we do not have to divide with symmetry. So this is one case, and the other case could be n square factorial divided by n factorial whole raised to n into, because all are having equal number, into n factorial because of the symmetry. Now in this case and also in this case, both cases must be integers, because number of ways of grouping n square objects into n different groups of having same number of objects has to be a perfectly natural number. So that means this has to be an integer, this also has to be an integer, okay. So using this basic logic, we have proved that this number is going to be a perfect integer, okay. So with this question we will close today's lecture. I hope you have enjoyed the lecture and also the logical discussion that we had. I hope you are going to use this to develop your own ideas, okay. So we will meet again in the next lecture with some more interesting ideas. Until then, have a great learning day. Learning shall never stop.